We're delighted to be joined by Larry Kotch. Larry is the CEO of Flybox, an insect technology company that designs, manufactures, and installs modular insect farming systems for the waste and food industry. Larry is also on the forefront of legislation on insects as feed and waste management through his work on the board of the UK Edible Insect Association and the Insect Bioconversion Association, which are involved in advocating for changes in law to accommodate and make use of the awesome power of insect bioconversion in the British economy. So Larry, over to you.
Thanks, Megan. Hopefully you can see me all right. I'll share my screen just now. So hi, everyone. Yes, I'm Larry. Thanks so much, REA, for kind of hosting this. Very, very keen to, keep banging the drum about, you mentioned there, the awesome power of insect bioconversion. I think it's got a lot of scope to help with our food industry, lowering its emissions and also providing a new income source. And so I'm going to go through sort of the basics. I'm going to assume that some people on the call at least don't really know quite how insect farming works. So I'll try and whiz through that and then get into the particularly interesting things going on in the UK and how that kind of stacks up with other parts of the world and some of these barriers that are maybe blocking the industry from fast adoption or for full-scale adoption. And then, yeah, if there's any questions, happy to kind of riff at the end. And I'll also link to some extra resources at the end if you want to dig in further. So with that said, we'll crack on and I'll try and yeah. So first of all, just what actually is insect farming? We often refer to it as insect waste management as well. Technically speaking, in this country, you can't use waste, but you can use byproduct, which we'll get into. But there are various different names. Insect bioconversion is the thing that's going, the actual active thing that's going on. So I always like to kind of start with the sort of circle of life scene in The Lion King to keep it really simple. I'm not sure how simple we need to keep it. Maybe this is too simple. But the circle of life is all getting at nature's zero waste design, that all of the dead plants and animals in nature are handled by decomposers, a decomposing layer that essentially breaks those that matter back into nutrients either for the soil or for other animals. And insects are key to that. They are nature's cleanup crew, nature's recyclers. And so in nature, there's a lot of biomass of insects, a lot of decomposing insects, which are taking all those dead animals and putting them back into larvae, which are fed on by omnivores, principally birds. Bird diets in the wild are very, very stacked with insects, as are, wild pigs and all the kind of animals that used to roam the land. And so what we want to do with insect farming, like with all the other, industrializing of agriculture, is to not tread over this amazing resource, but actually use it in our economy, which it, has unfortunately been ignored for a long time in human history. We want to correct that, apply the right technology, and to turbocharge it and intensively farm insects on waste. So just so you understand what the kind of life cycle is, the main species is the black soldier fly in the industry. If you look around, there are mealworms, crickets, different use cases for insects. I'm going to focus on the black soldier fly. The reasons should become apparent in a second, but for now, all you need to know is it's the best one. It's the best insect at doing waste management. And so you have, very much like a butterfly, you have a caterpillar, a cocoon, and then a butterfly comes out. Same with many insects, same with black soldier fly. So the female lays hundreds of eggs. They hatch into what we call neonates, so little babies, and then they turn into seedlings. They then grow up to their sort of fifth instar, which is when they're the fattest and the most full of protein. And at that point, then if you left them for another few weeks, they would start to slowly pupate. And then another few weeks, they would turn into, the adults would come out of the top, and then the cycle continues. The reason why I've drawn out these names, neonates and seedlings, is this is really where the industry is coalescing around. This is the bit that people are interested in, is getting the insects onto waste when they're this age is the sort of correct time. All of this over here is quite a hassle. The kind of foods they can use, really, another reason why the black soldier fly is picked is they're very versatile. So you can go from high value byproducts from the food industry to manures to grain byproducts to fruit and veg waste. Now, we will touch on regulations, but theoretically, they can eat anything that is not cellulose containing. So they won't eat green waste and garden waste, although you could ferment that if you and splice it in. But realistically, anything that an animal could eat or has already eaten is what they want to eat. They love manure. They're absolutely amazing at it's one of the best feedstocks for insects. Um, their larvae are the ones doing the eating. The flies do not have mouth parts. They are just there to mate, basically. I have a video here, and I thought it was actually just worth just playing because then you'll see what an insect farm looks like. So now you know what it is. This is just the most basic level, what it looks like. I'm going to mute it. So you essentially have fruit waste in this case. It's shredded into a kind of porridge. The insects have small mouth parts, so it needs to be cut into a kind of porridge. That then goes into a mixer. So often you're mixing different feedstocks, like with other animals, to get the right nutrition for the insects. Like any other animal, they have the macros that work the best for them. That different insect farmers will understand. Once that's kind of all mixed up, your recipe, it's essentially just dosed out into trays. It's important you can't just put them in a big bathtub or a big bioreactor. It has to be in trays because the larvae eat at a certain feeding density, and because there's so many of them in there, they give off a lot of heat. So actually, the kind of tray system has emerged as the right way to do things because it keeps all of the densities and everything at the right in the right way. This is a very crude sort of manual type of setup that you can see just because it's the best way of showing how everything works. You then introduce the juvenile larvae. So those seedlings I showed you before, they are about 5 days old from hatching. And so they are now ready to eat waste. They're kept in a nursery before this stage. And so, which is the finicky part, which we'll get into in the business side of things. But these juvenile larvae are then, popped into these trays. They're stacked, and it takes 2 people a day to do 900 of these kind of trays, which is about 9 tons of waste. Even in this very manual setup, there's obviously much more robotic solutions, which we'll get into in a second. Then they are put into a controlled environment. So this is controlled environment agriculture. They're built into towers. The climate control is extremely important. It's the most challenging part of insects. It's not the same as poultry or, shed HVAC. But anyway, we'll get into that in a second. At the end, you leave them in there for 10 days. When they're ready, they come out. So they've eaten all of the waste, and all you're left with is basically the larvae and the frass, so the fertilizer which is left, which is basically the residues or their manure after eating the waste. And so this can happen in a week or 8 days. So it's like a turbocharged composting is another way you could look at this. You then sieve the larvae from this frass fertilizer through a mechanical swing sieve, and you've then got your 2 products which you can then sell, which is a biopesticide, very rich 333 organic fertilizer with very high water retention, chitin, and all these other wonderful compounds that can be mixed with other things. And then you've got on the other side, obviously, the buckets of larvae, which can then be frozen or done or further processing. So that's just to give everyone a very easy way of that's what's actually happening on an insect farm. There's much more robotic ways of doing this, but that is what is fundamentally happening. How do I now? There we go. So in terms of what I just showed you, I showed you basically this part of the equation. So we helpfully try to split up the industry very much how poultry works, where you have the breeders, the growers, and then the processors. And that is what is indeed happening in the insect farming industry. In the beginning, it was all under one roof, everyone trying to do the whole business model. It was a kind of gold rush mentality. Very much the industry was trying to model itself around like alternative protein, like corn or like lab grown meat. And what's happening now is very much a shift towards looking at it as a waste management solution. And so in order to bring in the existing food and waste industry, what you want to do is simplify things. So simplification looks like centralizing breeding with economies of scale, with companies that specialize in that breeding. This requires entomologists. It requires a lot of finickiness to get the juvenile larvae, the 5-day-olds that you saw going in, at a nice consistent size in the volumes that are needed. And what most people want to do is deal with waste. So at this point, all they need to do is have waste go through grinding machinery into a porridge, introduce the larvae, grow them up, and then sieve them. Then what you want is someone to guarantee the buyback of those larvae and the frass and deal with the end product, customers, ingredient sales, or on the other side. The industry so far has literally been doing all of those things per company, and you've had this insect industry trying to do basically a vertically integrated farming solution, and that has caused big problems. You've probably seen some of the failures that have happened in Europe recently, like insect. It's an insane amount of risk to try and take on that whole piece, and thankfully those lessons have been learned, and the industry is now modeling itself much more on kind of traditional ag. The scale you can go is obviously I've showed you the really basic setup, essentially like this sort of thing, like a kind of pilot farm. Flybox has built the various different scales of these around the world, several in the UK. And then you've got full scale farms where you're talking about robotics, where you're reducing the labor as much as possible. And that's where, everything is basically handled by automation software. And so you've got a more or less fully automated farm of scale. So this could be 1 to 5 tons a day of waste going in. This would be something more like 20, 30, 40, 50 tons of waste a day going in. And so key to this kind of growth of this industry will be the outsourcing. So new operators getting into this space now have the option to deal with off-takers, to get contract in the seedling and egg supply, to actually outsource the sort of feed and nutrition services to work out whether their waste will work, and even to actually source feedstock from waste management companies who are now getting into the space. And the end market, so where you then sell the larvae. So the main one at the moment is aqua and pet food, and there is a niche market for human food, but not necessarily more BSF. It's more with the crickets that works. Then you've got the frass manure, obviously an organic fertilizer, soil conditioner. So we can talk more about that after. So getting on to the strategic importance of all this for the UK, now that we've got the basics out of the way. As we all kind of appreciate that we're wasting a lot of these nutrients. So just, take the environmental side out of this completely. It just seems silly to waste so many billions. I think it stands at, several hundred billions of dollars a year when you add it up globally of wasted nutrients, just the value of the nutrients going into landfill or into suboptimal routes. And food and agriculture are a third of all global emissions. There's a lot of, people, mouths to feed. And, waste managers and companies and food producers are they're either under pressure by regulators and new schemes coming in, or they're kind of consumers asking them to try and push the bounds and do more innovative things and do more circular solutions to waste. And so that's where this sort of fits in, the emergence of this as an option. And this is really compounded by, as everyone might know here, the simpler recycling scheme, which is being rolled out at the moment, and will be fully in effect by 2028. And so this is going to force a separation of organics from the other material streams, and that is going to put a lot of pressure on our existing organic waste treatment infrastructure, which is mainly anaerobic digestion. And so, how are we supposed to build the capacity? I think the ADBA did a capacity gap analysis and worked out that by 2030, if we built nothing today, we would be 1.5 million tons of capacity short for dealing with organic waste. And if you bear in mind how long it takes to build an AD site, and how, in order to monetize food waste AD, or, the food factory system able to take food waste, you're talking 7 years to connect it to the grid under Ofgem's latest guidance. So, and because of the compliance costs and the kind of on costs and the grid connection costs, it doesn't really make sense to build small ADs. Everyone is building these large mega ones, which have a very large catchment area. Where insects can fit in insect waste management can fit in is providing those regional, on-site, on-farm, next to food clusters, local waste solutions, the more regional solutions, even company level solutions, rather because they completely skirt around the grid for monetization. It's the protein, so it's not required a connection to monetize for grid for gas or electricity. It's not just the UK, by the way, as well. We are it's a sort of global trend. These new schemes for separating organics. I mean, it's across the world. Um, and yeah, and so compared to a lot of these other methods, there are, and I'll link to the white paper at the end of this that you can read. We a whole research document looking at the thermodynamics, the kind of how energy is converted across all of these different methods, and the economic value under certain assumptions and regulatory environments. Insects are consistently seen as high up there, in potentially even higher than AD in terms of valorizing organic material. It's not the reason why the insect waste industry is not larger than it is a creature of human reasons. So it's not because the physics don't make more sense. It's because there are subsidies for anaerobic digestion. There is a kind of consumer acceptance, and there is not um, the network yet that can enable lots of people to get into insect waste management. It's like a network problem as well as a regulatory problem. If you started subsidizing insects to the same tune as AD, and you allowed insects to eat manures, for instance, which we'll get into in a second, no one would build another AD site. It's just that's not possible right now. So, well, at least in the UK. So there's the use cases are more restricted than they otherwise might be. So it's just to say that sometimes you look at these different technologies, but when I got really excited about insects was when you go to the underlying physics of the thing, so how energy is actually converted along into something of value. And so I'll link to that at the end. In any case, insects sit at that sort of waste to farmer in terms of the chitin, waste to food, waste to feed, which is much higher up that food waste or the waste pyramid. What we want to be doing is a circular solution, keep nutrients in the food system rather than essentially just burning them via incineration or burning the gas off them. So, currently right now we're just burning our waste in different ways, but this is actually keeping food within the food system, and not requiring kind of more virgin resources to enter into one end of the food system. And so obviously in the UK, being an island, relying increasingly on food imports, it becomes a kind of food security thing to actually try and keep as much of that material cycled in our economy. It's also, not to say that there's a direct competition, certainly not in the until regulations change. This is what I like to show as the kind of the gas potential, versus it's basically, this is just showing that ADs want things with high gas potential, and these also are things that you cannot use for insects anyway. And it just turns out that the things you can use for insects, like market waste and straw, are the favorite thing of insects. So they actually target different feedstocks in the short term. So if we were going to design like a national strategy top down, we would probably want insects to handle more of the fruit and veg stuff that, obviously first the stuff that can go to charities, stuff that can't go to charities, you would want, to feed directly to animals. Sugar Rich and these other kind of companies, they don't tend to want to mess with fruit and vegetables. They prefer the higher calorific, biscuits and sugars and all of that. These guys, especially in the context of simpler recycling scheme, are already finding it very challenging to find anywhere that will take this kind of material. ADs are going to slowly start boxing out all of the fruit and veg waste that they've never really liked in the food waste digesters. Now that they have ample amounts of, limitless food waste that's going to be coming from the simpler recycling scheme, backed by councils who will never go out of business. It makes much more sense as an operator to just contract out all your capacity with local authorities, and rather than entertain these less gas yielding wastes from the food industry, like the food factory waste. So, and then given how long it takes to build new AD sites, we're talking about a very nice opportunity where insects can play a role. There's also the direct CO2. There's been many LCAs done, comprehensive. This is also in our white paper, but insects is about double or more the CO2 abating power of AD. So encourage everyone to read that. I'm not going to get into the whole LCA side of things. And then in terms of the waste industry players right now in the UK, so there's a bit of in general, there are multiple large waste managers who are getting into insect farming now. That's been the new pivot. You've got people like the Schwarz Group with their brand Pre-Zero in Germany. Veolia has bought multiple insect companies around the world now, and they're kind of a leader in the space. You have the sort of traditional insect farming companies like Protix and Innovafeed, which came out in the EU, very heavily funded. But in the UK, you're seeing the sort of more SME style waste managers really embrace some of these things. One of our customers is called My Group. They are building a insect waste management center, and they're growing it quite rapidly this year. Packaged Feeds is another company that's sort of similar size, that's gone really all into insects as their waste management solution. And they're finding they're able to win customers a lot more by being able to offer a new solution to waste. You know, everyone is just saying, we'll chuck it in AD, we'll chuck it in AD. This is a new thing that they can do. And there are recently a company called Fairman Knight and Sons just has the intention to build a 50-ton-a-day plant. They've already secured the land and have already started building their first phase, which is already operational. And you have some smaller players as well, like Fly to Feed, which is also one of our people. And then in the US, you've got the food industry stepping in, and the big deal was done by Tyson Foods and Protix for a mega factory over there. And then in East Asia, you have some very successful companies doing this. Different business model over there. They're leveraging the local environment a lot more. But I'd say in the UK, this kind of joined up approach is really, really working in a way that is different from Europe. And I'm very excited about it. And that's why we're very keen on the UK market. And so that joined up approach essentially looks like you contract out the juvenile larvae. They arrive to an insect waste management site built by us or whoever. There's other players out there, and the products are bought back at a guaranteed price. So that then, it opens up the doors to companies for smaller sites that have much less capital commitment and are much less complex, because the kind of upstream complications and the downstream complications are sort of contracted out, and so it makes the P&L a lot more predictable. And so that's what we see as the real opportunity that's driving now. There's similar efforts going on in Europe. There's several companies that do a similar thing to us and do a similar thing to this now. And that's the way the industry is moving in this next phase, is joining up the dots and having these specialist companies that provide the breeding or provide the offtake. And then the bit in the middle is the people with the arbitrage, the people with the waste, the people with the local waste issue, being able to leverage this technology without having to do everything themselves and figure out all of the science by themselves. And the sort of, if you look at AD, its growth 40 years ago, if you went around telling people you were going to build an anaerobic digester, and that was a solution to the UK's waste management problems, you'd have probably been laughed out of the room. If you went to I think the first food waste AD was in 2010, 2011, discussion started. So we're talking about, once these things get going, they can see a rapid uptake, as has happened with AD. And I think the insect side of things, definitely, as far as people that advise our company that were part of their building of AD, they see a similar promise with insect waste management. And it's heavy infrastructure, it's deep tech, it takes time, but that's what you can kind of, that's kind of the chart that you'd model the insect industry is modeling itself after. And finally, just on the regulatory side of things, probably the last section. So in terms of, I guess the first one to talk about is feedstock challenges. So I've given a nice rosy picture about, okay, you get the waste and you give it to the insects and they turn it into product. But in practice, just like with AD, it sounds very simple. Oh, you've got a big digester, you dump the waste in, gas comes out, and everyone's happy. In practice, in most AD sites, it's a very carefully managed chemistry, with chemists, obsessing over what is going in that day or that week to not upset the ecosystem of bacteria they've got in there in order to monetize it. So yes, you can chuck anything you want into a digester, and yes, eventually you will get gas out of it, but it's about how efficient can you be, how much money can you make from it, how profitable can you be, and to get each of those incremental steps above, you have to get ever more precise on what you're doing. And it's exactly the same with insect waste management. you can't, they will eat anything. You could just, chuck some larvae into a bucket of chopped up fruit. They will eventually get through it all. It'll just take them a month. Whereas if you crush it into a porridge that it has small particle sizes for their mouths to eat, and you combine it with the right macros, they will grow much quicker and provide a better product. So it's always a balancing act. You can approach this space as, I have this waste problem and I want to get rid of it in the best possible way economically, and you start with that, and then you look at what's the least cost, least complication way of achieving that. Do you need to bring in other material? Where would you source that material? What's the kind of cost benefit? And so during any new insect setup, this is the biggest challenge, is people don't have the understanding yet of how the feedstock actually works. It's not just the nutrition. The insects live in their feed, so you've got to work out the environmental characteristics. Some wastes go cold, some wastes run hot, some give out more ammonia, less. These things have an effect on the biology of the insects. So it's the viscosity, how fast can they move and eat. All these things are actually considered when you're designing your diets. And so this is a big challenge, is people having access to that kind of skill set. As you can imagine, there aren't hundreds of insect nutritionists running around the place, but that's one of the big challenges, how you scale that part. We can talk about that later. There's obviously many solutions to that problem, but it's just one area to be aware of, is people who are interested in this space often rush in thinking it's going to be a simple thing because the industry tries to paint it like that, but it is actually a huge challenge, and it takes months of work to get to a place where you're happy with it. But the good thing is that most of that work can be done on paper with a nutritionist, and can also be done in very small scale trials in order to then plug in the assumptions for a larger business plan. So this is just a bit that people should not underestimate, and should, every week spent doing this and not building an insect farm is worth 10 weeks of production problems. So this is an area that will require more standardization, more go-to diets, and in fact, more go-to feed that is provided for by waste management companies. So this is an area that we're actively involved in with different waste companies, and is very, very exciting. But if anyone here is looking into this space, this is the bit that is where the question marks always lie. In terms of the waste regulations, so technically, because insects have been classed, or black soldier fly and other insects have been classed as farmed animals, which means they're in the same category as sheep or pigs or chickens, and therefore you cannot feed them anything you could not feed an animal. And so that restricts quite a lot the waste you can feed them with. So it's really byproducts that you can feed them with. So that's everything from a food factory. You can feed them eggs, you can feed them dairy, you can feed them vegetable wastes, but it cannot contain ABP. So you can also feed them supermarket waste, again, without ABP. So you can depack non-ABP foodstuffs that have expired, but not not containing ABP. You obviously can't feed them manures, which is like their perfect diet. And that the concerns around there are around prions. There is, if anyone has questions on prions, it's been categorically looked at by the Safe Insects group in Wageningen University. Many millions of euros went into studying the effect of prion transmission, and found there's no increase in transmissions. So this is a discussion that's going on between the associations we mentioned at the outset and DEFRA, but there's also a kind of political element where DEFRA has a lot on its plate, and it's one of those chicken or egg things. There's a potential big industry here if it gets the focus of DEFRA, but DEFRA only wants to focus on big industries. So it's sort of like one of those, chicken and egg. And so part of increasingly what I'm doing is spending most of my time now thinking about the sort of political will side, and really communicating the economic, jobs and green growth benefits that then will trigger the, hey, DEFRA, they know about all of this stuff. They're in dialogue with the insect industry. There's plans afoot. There's a consultation that went out very recently to push things forward as well. So it's all on the agenda. It's just to speed it up on the agenda. What we want as an industry is to increase the amount of waste we can use, starting with things like supermarket ABPs and catering waste, and then looking further. Right now, you can feed the insects at the end to aquaculture and pets as proteins. You can only feed live insects to poultry and pigs. You can't feed them processed proteins. This will change by the end of the year. As I mentioned, there was a consultation that went out with the aim of bringing us in line with the EU, which already allows processed animal proteins to be fed to poultry and pigs. So that's just all in motion at the moment. There's no blocker for that one. So we will be in line with the EU. We missed it as we had Brexit just after they ratified this whole amendment. And just should say as well, with anyone who's kind of watching the space keenly, the direction of travel has always been, number of approvals have been increasing every year in relation to insects. So whether it's the EU or the UK, the direction of regulatory travel is always to liberalize it as the information is communicated to the right people about the safety of insects. Insects are antimicrobial. So the reason why they're able to safely consume manures and other things that would make other animals sick is because they literally eat pathogens. I mean, in the past, one used to put maggots on to treat wounds. They actively clean the environment. Inside their stomachs are these antimicrobial peptides, a far wider variety of ABPs than AMPs than we have as humans and other animals. And so, even eating a few amount of insects, especially live insects in poultry diets, really helps them actually transfer some of that immunity in them, and it becomes a kind of pharmacological supplement, not only a kind of protein play. And so for that reason, you expect this to liberalize. Whether or not the UK will ever let insects eat manure and have those insects go back to the same animal, that's probably a long way away. If a lot of people would have to see a lot of information before that happened, but potentially feeding the larvae to different species that have been fed on the manure of another species, potentially you could see a route to that, in many years. But right now, even to just sort of edge out the EU's relative competitive edge, if we just allowed catering wastes and supermarket ABPs, which have already been processed, and the insects are being processed anyway, but if you just put those two on the table, we would completely dominate the European market. Like, everyone would want to invest in insect farms in the UK rather than France or the Netherlands, because the substrate costs would fall immediately. So the P&L would just look better, assuming we can sort our electricity prices out. But hopefully that will happen. And then, so another thing, it's not really a challenge, but it's something that is happening and needs to happen in order to make this even more sexy as an industry. I've just put here the kind of FCR improvements and the kind of market weight improvements of poultry. So since 1957, the selective breeding of broilers has improved dramatically the amount of weight they can put on, how fast they can put it on, and their feed conversion. And so insects have a much shorter timeline. There is a company in the UK called Beta Bugs, whose entire shtick is the selective breeding. At some point in summer this year, they're coming out with their Hyperfly genetic strain, which will aim to double, it might be 50% better all-round improvement than your kind of traditional just fly, which they call it, which would mean faster development and also larger larval biomass in the same period. So that's very exciting. There's a lot of research on this area. That massively changes the economics as well, because you're getting the same, more protein out of the same waste source. And I think I did just touch on it. And this sort of live larvae, I think if you actually boil it down, there's one thing, which is price. So if you are able to add these feedstocks in that I mentioned, you could see right now that insect protein is too expensive to include in most and certainly in animal feed, it's just a non-starter. It's far too expensive as a insect powder, something like 6-7 times more expensive than soy. So it's a complete non-starter if anyone's thinking that that could be a link. Um, Pet food, it's a little bit more sort of on the edges, and some aqua, but the changes that the industry is advocating for at the moment, this also depends on who you are as an operator, by the way. So I'm just giving the example of a fresh operator with no opportunities. One of the companies we're hopefully going to be rolling out a farm with later this year have an amazing situation where they have essentially free labor based on the kind of seasonal labor they already have. They have renewable electricity because of their location, and they have a massive waste problem. They're fruit and veg distributor, a really big fruit and veg distributor, and they are being charged out of the nose and not going into AD. No one wants their material, and they're being charged out of the nose for disposal. So when you add all of those benefits to them that accrue, they can produce insect protein at half the price that the traditional people can, and that's why this technology needs to be with the food industry and not with an insect industry that's trying to recreate and source feedstock. And you really want these local opportunities where those arbitrages exist to be empowered by the tech, rather than trying to create a separate industry that's like trying to do everything from scratch again. And so in those scenarios, you can be competitive with insect protein today. With sort of fish meal, that sort of price, you can get to within very close distance of that. But if you really boil it down, the live larvae is actually where a lot of interesting things happen. I mentioned these antimicrobial peptides. So these larvae, when they're eating through waste, the amount of AMPs that they produce then get transferred into the guts of animals that they eat. As far as poultry go, they, it's an absolute welfare gem if done in the right way. The larvae it's like Netflix for chickens, in their sheds. It really provides that kind of natural pecking behavior. You can use it to control crowds or bunching, inside the actual sheds themselves. We're embarked on the one of the largest grants in the industry, looking at valorizing the live larvae at a 1% inclusion, so a few grams per bird per day, where it's not just the extra kick of a nice animal protein. It's really looking at the pharmacological, the sort of and really all cause mortalities, how the larvae affect the survivability and the sort of all the negative traits that can occur inside the sheds between birds, how those are limited, and quantifying those so that in the future you could see a really cool place for how live larvae can be used, not just on the protein side, but as a welfare enhancer, like a big welfare enhancer. And there's some big poultry companies involved in that grant, along with an AI partner that's documenting with camera systems all of the changes that occur when the larvae are distributed. And we've created a distribution mechanism to distribute the larvae in spot places, so they can drop in different places, so you can control the flow of the birds somehow as well. And yeah, so that's just an example where I'm just saying this is the live larvae side of things shouldn't be overlooked, because that's where a lot of the benefits for animals can actually lie. Not just looking at it as a protein, but looking at all these interesting immunity boosting and other health benefits. So yes, that's kind of the sort of challenges and the things that are being looked into by the industry to really sort of unlock it. And in terms of any further information you might want, we do offer farm tours in our UK demonstrator, which is in Chesham. We have other companies using our stuff in different parts of the UK that might be open to letting you take a look around case by case, but certainly ours is always welcome. So if anyone wants to see what goes on in an insect farm, then you can always just get in touch. And on our website, if you want to dig into the economics and the physics side of things that I mentioned at the beginning, how that all compares against AD and pyrolysis and all these other methods, we have a white paper where we've done that, which is has all the references that you can go and take a look at. So if you want to get sort of nerd out a bit into this stuff, you can get that from our website in the resources section, and that should probably be too much information, or definitely enough information to satisfy even the most curious people about this. And yeah, and I think with that, I think we're probably at the 43 minutes. So probably leave it there, Megan, and happy to do questions. And yeah, hope it was useful.